In our final video here for lesson 2-3, we're going to address this concept of resistance. I've already mentioned that the mean is going to be strongly affected by the presence of outliers or a long tail in one direction or another, whereas there are other measures of center that will not be affected, and therefore they are resistant. So the mean is non-resistant. It cannot resist the urge to move when an outlier is present in a data set. So if you have a high outlier, that mean is going to be pulled in the direction of that outlier. If you have a low outlier, that mean is going to be pulled down in the direction of that low outlier. So one way to help you remember this is that it's mean to pull a dog's tail, meaning the mean will always be pulled in the direction of the tail of a skewed distribution or in the direction of an outlier. Okay, so to be non-resistant, it means that it cannot resist the urge to move. It will be affected. Okay, now when you have a distribution that is skewed one way or another, like the picture here, the histogram on the left is clearly skewed to the left. The histogram on the right is skewed to, in the middle, excuse me, is skewed to the right, and the histogram on the right is relatively symmetric. If I were to make a box plot, which I will here in a moment, and we'll be talking about that here in a future lesson, you'll see a similar skewed left, skewed right, and symmetric. So when you have a skewed left distribution, we said the mean is going to get pulled downward towards that longer tail. Therefore, the mean is going to be less than the median because the median's not going to change. The median's going to stay right around where it is. We say that the median is resistant to outliers. So the mean is pulled in the direction of that left tail, making the mean smaller than the median. In the skewed right distribution in the middle, the mean is going to be pulled upwards towards that tail to the right, meaning the mean is going to be greater than the median. And in our symmetric distribution to the right, the mean and median should be about the same. They won't necessarily be exactly the same, but they should be about the same. Now, if we were making a box plot, which we will be making these next week, we're making a box plot. The box plot shows what's known as the 5-number summary. It has the minimum in it. It has quartile 1, the median, quartile 3, and the maximum. And we talked about the fact that those 5 measures separate the data set into 4 quarters. Okay, so we'll go into this in greater depth next week. I just wanted to give you a peek into what a box plot is and how it compares to a histogram for the same data. So clearly for our distribution on the left, the min has to go all the way to that left tail and the max has to go all the way to that upper data value. The median is the one in the middle, and that's the red line that you see inside the box of that box plot. We often refer to this as a box and whiskers plot. Quartile 1 is the middle of the lower half of the data. That's the left side of the box. And quartile 3 is the middle of the upper half of the data. Again, we'll go into much greater depth on these box plots next week. But you can see what the box plots would look like for these particular histograms.